okay, using functions involving e. E on your calculator, if you take a look on your calculator, you have a button that says LN. Do you see the button that says LN?
Yes. Two below.
That stands for natural log. E is associated with natural log. We're gonna start doing logarithmic functions. So if you press second and LN, you're gonna get e to a power, okay? That's what you're gonna have to use on your homework tonight, 90% of it, okay? E is known as a natural base. So you know how in mathematics you were introduced to pi, and what does pi stand for? 3.14 if we round, but it goes on forever, right? It's a special number in mathematics. E is a special number in mathematics, okay? And the reason it's named E is because it's named after the guy that discovered it, who's Euler. His name's Euler, so they just named it after him, okay? So as you plug in positive numbers to e to the power, it approaches positive infinity. It's going to increase, okay? Look at this. E stands for this portion right here. What does this portion look like to you? It should look familiar.
Oh, it's the one that we did before.
It's what that we did before.
The one in the last,
Yeah, it was the
yeah.
What
where it
form?
was like A.
Yes.
Exponential growth.
Exponential growth, okay? It's part of my exponential growth when I'm dealing with compounding interest or continuously compounding, when I'm dealing with compounding interest. E stands for that whole thing right there. Okay? So I can now replace that part of my equation with E. If you put E into your calculator, what number does it come out to be?
2.7.
Yeah, it's, okay, so if you put e to the first, like on mine, you have to put e to the first, which means it's e. You get 2.718281828, yes?
Yes.
Okay, so do you see how it has a pattern? It's repeating 1828, 1828, 12. Okay, what it's saying is, as I plug in higher powers, okay, 2, 3, 4, 5, 6, 7, as I plug in higher powers, what do you notice about the outputs?
Is bigger.
But not drastically bigger. What's happening there?
A tad.
Look, 2.5, 2.7, 2.71, 2.718, 2.7182. Yes, the pattern is coming. 2.71828. And so if I put the 6th power in, I'm going to get another 1. And if I put in the 7th, I'm going to get another 2. And if I put in the 8th, I'm going to get another 8th. And it's going to continue to go like that. Okay? So, it's just a special number that we have in mathematics. Oh yeah, I need to delete this. I don't know why there's a graph. Listen, this is actually really easy.
Makes me terrified.
Can I go
No,
to
no.
my calculator?
I'm sure you just
Sure.
type in these. E to the second times e to the fifth equals.
Why is this not working? Okay, so if I am simplifying an expression, you're literally going to apply the rules of exponents to this. Simple, okay? That's why you have to know the rules of exponents. If I have e squared times e to the 5th, these bases are the same, right? So I have e to the 2 plus 5, which gives me e to the 7th. If it says simplify, I can leave it at that. If it says solve or evaluate, it's going to say evaluate in these. Then you're going to put it in your calculator and give me a number. Round it to like 2 decimal places. Okay? But if it says simplify, I leave it as e to the 7th. When I have 12 e to the 4th over 3e cubed, I do 12 divided by 3, which is 4, and I have 4 minus 3, because when I have powers, I subtract them. So I get e to the 1st, or just 4e. I can leave it. Okay? Over here, I have a power to a power, so I square 5, yes? And then I have e to the negative 3x also squared. And when you have a power to power, you multiply. So I get 25 e to the negative 6x. Why am I not done yet? Can't have a negative exponent. So what do I have to do with e to the negative 6x? Flip it. So you get 25 over e to the 6x. So the first part of your homework is gonna involve simplifying, okay, with Euler's number. So you're applying every rule that we've learned for exponents and just using it on Euler's number to simplify, okay? This should be nothing new. This is why you should know those rules. Expressions, if it says evaluate, or if it says evaluate the expression, you're literally gonna plug this to your calculator. What's e to the fourth? 54.598, right?
Yeah.
So I can't round to 54.59, I'm gonna round to 60. Okay, round to 60. Or I'd round to 59.6 or 54.6. I don't know why I said 60, because I was thinking it was 59.
Right.
So you're gonna round to 54.6 or 55, it doesn't matter, okay? I put the congruent sign because it's not equal to that, it's congruent to it because I'm rounding. What do I get when I have e to the negative 0.09?
0.91.
You get 0.91, so it's congruent to 0.91. Can you handle evaluating?
Mm-hmm.
Okay, so first two things are simplifying, second is evaluating, third is going to be graphing. Okay? When we go to graph natural base, it's very simple as well. Okay? So natural base is an exponential function. Okay? It is exponential. So you have exponential decay and exponential growth. What tells us something's exponential decay?
Negative.
Nope. Negative does not tell us.
Negative exponent.
A number what? Less than 1 and greater than 0.
Oh, okay.
So if my b, if my base, right, in the formula y equals a b to the x, if my b is less than 1 and it's greater than 0, I know that it's decay, correct? Same concept is going to happen here. Except for here's the deal. Your rate is what's going to tell you what's going on, because your base isn't going to change. Your base is going to be E on both growth and decrease. Okay? My base is E 2.7182. Okay. What tells me if it's growth or decay is this R right here. Do you see how this formula is a little bit different? It says y equals A times e to the rx. R is your rate. So if my rate is negative, I have decay. If my rate is positive, I have growth. So on these ones, you're looking into your exponent only when you're dealing with Euler's number. When you are dealing with normal growth and decay, you're looking if that b is a fraction or not. Okay? That's the only difference between these two formulas. Okay? So I have exponential growth if my power is positive, and I have exponential decay if it's negative. With that being said, I can graph, and we're going to graph both of these on one, and we're going to take a look at what that. It's not hard. It's very simple.
Why did you do that? Why did you squeeze it? What's my question? Why did you do that?
Okay. So let's graph these. I'm going to start. Okay. We're going to graph the same way we've been graphing. We're going to graph if there's an H and K that shift. We're going to graph the little thing, and then we're going to shift it at the end. Okay. It's the easiest way not to make a mistake. So that's what we're going to do and how we're going to graph all of these. Plus, that's how Mr. Rice makes you graph in his class. He makes you show him the shifts. So we're just going to practice for him as well. Okay, let's start here. If I want to graph y equals 3e to the 0.25x, I literally can just plug numbers into that. Okay? Now, is this going to be growth or decay?
Decay.
Why?
Because, what did you just say? I just forgot it. It's because it's not.
What's my rate? 0.25. Is it positive or negative?
Positive.
So it is
Oh, growth.
growth.
Okay.
My rate is always right beside my x. So if my rate is positive, I am growing.
Yes.
Even if it's a fraction or it should be a decimal. Your rate is a decimal because you're doing 5%, 25%. Okay? If your rate is positive, you have a growth. Now on this, you literally cannot do this without a calculator because there is an e in there. Okay? You cannot do your homework correctly if you do not have a calculator. You will fail your quiz on Thursday if you do not have a calculator. Bring it to class. I'm going to plug in -1, 0, 1, and 2. Just easy numbers. Okay? Nothing hard. And I'm only going to -1 because I know it's growth, so I don't need to go that far into the negatives, okay? If I plug a -1 in, that means I have 3e to the -0.25, correct? So what do you get when you have 3e to the -0.25?
0.78.
I'm getting two different answers.
Oh,
That's what I got 2.3.
oh, alright.
What did you do wrong?
Oh, well, it's just because I didn't multiply by 3, so I just.
Multiply by 3.
Okay, who got 2.3?
Yes.
That's what you should get.
I still want
2.3. Okay, now, be smart here. I don't really have to do much math at the beginning. If I plug 0 in, that means I have e to the 0.25 times 0, so I have e to the what power?
1,
0, which means 1, so what is my answer?
3.
3. Okay, don't even have to do math. Now, if you plug 1 in, you have 3 to the e times, 3 times e to the 0.25, right?
Yeah.
And what do you get there? 3.9, if I round it. Okay, what do you get when you plug 2 in? 4.95? Yeah, 4.95. Okay. What?
So we can just round up to 5.9.
I'm not gonna round to, I'm gonna probably round to 1 or 2 decimals because Euler's number is special. I wanna keep it as close as I can to it. You're going to have lots of decimal answers on your graphs. Period. It's not, there's no way around it because Euler's number is a decimal that continues. So it's not gonna be any different. So when I go to graph this, I'm gonna graph -1, 2.3, right? Something like this. I'm gonna graph 0, 3. I'm gonna graph 1, 3.9. And I'm gonna graph 2, 4.95. So my graph looks like this. Tell me domain. Yes, and what's my range?
Any number above 3.
X is, or Y is what?
Greater than 3.
Y is greater than 0. It goes lower than 3. It's right here, 2.3.
Oh, okay.
Y is greater than 0. There's my domain and range. Now, over here, we are going to focus just on this part of the formula, and then we will shift it with my H and K. Does that make sense what I'm saying?
Yes.
Okay. So we're going to plug in -1, 0, 1, and 2 again. Now, before we do that, tell me, is it growth or decay?
Decay.
Why?
Negative.
Negative what?
0.75.
Okay, my rate is negative. My 0.75 is negative. So I should have a graph that goes like this. So it falls this way somehow. Okay, it's going to fall. It's decaying. I'm going to graph it, then I'm going to shift it. Okay? So if I plug in -1, 0, 1, 2. Let's see what we get when we do this. When I plug in a -1 up top, that means I have -1 times -0.75. So you have e to the 0.75. What do you get when you have e to the 0.75?
2.1.
2.1. Beautiful. What happens when I plug 0 in? You get 1. What happens when I plug 1 in? That means I have e to the -0.75, right? So what do you get? 0.47. Good. Do you see how it's getting drastically like smaller right there? That's a good thing. Okay. And then if I do e to the -0.75 times 2, what do you get? 0.22. Okay, let's graph this. -1 is 2.1.
1.
This is 1, this is 0.47, this is 0.22. Now, what do I have to do with these points?
Mobile.
Okay, what's my H for shifting?
2.
It's +2. What's my K? 1, so I'm going over 2, up 1, over 2, up 1. Over 2, up 1. Over 2, up 1. Over 2, up 1, and over 2, up 1. Here's my graph. Now, what is my domain,
All the numbers.
and what is my range?
Y is greater than 1.
Y is greater than what? 1. My range always comes from the K. I cannot stress that enough. What?
How do you plug that?
Oh.
Like when you plug the numbers in, so I got the the E thing, and then I got 0.75, and then that is right.
No. You have to use more parentheses. You're gonna press that E thing, where's your L in? And you're gonna put 0.7, well, you're gonna put negative 0.75 into parentheses, then parentheses again with the 2. And then it will give you, because she was plugging 2 in for the power of X. That's what she was doing.
Oh,
You
okay.
gotta find the Y.
Okay. Okay,
So, well,
what?
when you take when you take -1, you still subtract it from 2, and then
When you take negative 1.
when you plug that in for x.
Okay, no. When I'm plugging in for X, I'm literally focusing on this part of the equation.
Okay.
The negative 1 and the negative 2 and the 1, we'll do at the end with the shifting like we just
Okay.
did.
Okay.
Okay.
Answer my question.
Keep it in the simplest form, e to the rt,
Okay.
okay?
Thank you.
Okay, now, if we had graphing calculators, we would definitely do more to this problem. But we're gonna just talk this through because there's not much to do. They give you an equation that says the length in centimeters of a tiger shark can be modeled by the function 337 minus 276e to the negative 0.178t, where t is the shark's years in age. If we had a graphing calculator, we can plug that in, press graph, and we can read a bunch of stuff. If we don't have a graphing calculator, we plug in numbers, and then it kind of sucks because we're going to have this massive graph. But I wouldn't make you graph this model. I would, however, make you figure out how long the shark is at 3 years.
Plug in birth,
To what?
so T.
To t. And then you just solve from there. Okay? And you give me an answer, and we get it from there. So that's what it will look like a little bit on your homework. The last thing we need to talk about is compound interest. Okay? So, compound interest, we talked about this yesterday with this formula right here, yes? A equals P 1 plus R over N to the NT compound interest, okay? There is a formula for continuously compounded interest. There are 2 different things. One compounds just on the original amount. The continuously compounded interest compounds on even the interest that's put on. Does that make sense, what I'm saying? Okay? So when you're doing continuously compounded interest, you use a formula that says A equals P E to the RT. Because remember, E replaces this whole segment when we looked at it, yes? Okay? E is that segment, so we can replace it to get our continuously compounded interest formula. So it's A equals PERT. P E to the RT. Okay? For some reason, people mess this formula up more than anyone. It should be the easiest one because it basically spells a word. Just put the letters in order and you should be good to go.
So do we have to have most of the memorized formulas?
You have to have them all
Most of the
memorized.
memorized formulas.
Yes.
I don't know what I was trying to say.
So then we come to problems like this where it says, you deposit $2,500 in an account that pays 5% annual interest compounded continuously. This is the key to what formula I'm using, which would be A equals P times E to the RT,
That's pretty good.
okay? Continuously compounded means I'm using that formula. If it's just compounded interest, I use the one with the 1 plus R over N to the NT, okay? They want us to find the balance after each amount of time. So how would I solve this? What would I plug in?
2.
2? Oh, to what?
Well, okay, plug in your money.
Okay, where's your money go? Where's your $2,500 go? P, your principal, okay? And then E is not going to change. What's my rate? 0.05. 5%, 0.05. Your rate is always a percentage. You turn it to a decimal. And then your T is
Plug in whatever.
2. What do you get when you plug that in?
What is that? $2,761. $2,761.
Yes. So 2,762.93. 2,762.93. Okay? And then I would just plug 5 in for t and I'd plug 7.5 in for t to find the other two. Does that make sense? Okay? Everything you are doing tonight on your homework should be calculator work except for simplifying. When you're simplifying, you're applying the rules of exponents, which is the first section of your homework. The homework is 3 through 47 odd. Listen, only 3 of those are graphs. The rest are simplifying, telling me what type of growth or decay I have going on, or solving by plugging it into your calculator, okay, by evaluating. Get busy.